Is there a way to subtract rational numbers without using models? For example, how can we find the answers to negative 25 minus 75 and 1.5 minus negative 1.25 without using models? In this lesson, you will learn to subtract rational numbers by using an algorithm. Let's review. When we add numbers with the same sign, we move in the same direction on a number line. When we add positive numbers, we move to the right, and when we add negative numbers, we move to the left. When we add numbers with opposite signs, we move in opposite directions. In the problem negative 7 plus 5, we move 7 units to the left, 5 units to the right, and the answer is negative 2. When we subtract a positive number, we move to the left. When we subtract a negative number, we move to the right. A rational number is any number that can be expressed as a fraction. They include numbers like negative 1.5, negative 4, 0, 2, 3 3/4, 25 hundredths, and negative 5 3/10. All of these numbers can be placed on a number line. A common misunderstanding is to think that integers and rational numbers are unrelated. However, if we look at this graphic organizer, we can see that this is not the case. In fact, integers are a subset of rational numbers. When we use the term rational numbers, we are also including integers. Let's observe a pattern. We can see a pattern of adding positive 2, adding positive 1, adding 0. One way to continue the pattern would be to subtract 1, subtract 2, and so on. When we look at the answers, we can see that they're decreasing by 1. We can assume that the next two numbers would be negative 6, negative 7. Another way that we could have continued the pattern would have been to add negative 1, add negative 2, and so on. This still would have allowed us to continue the pattern in the sum. The equations on the left are equivalent to the equations on the right. Here's another pattern. We can see that we're subtracting 2, subtracting 1, subtracting 0. One way to continue this pattern is to subtract negative 1 and negative 2. We can see that the answers are increasing by 1, and we expect the next two numbers to be 5 and 6. Another way we could have completed this pattern would have been to add 1 and add 2. The answers would still have been the same. The blue equations on the left are equivalent to the green equations on the right. If we take another look, we can see that when we subtract a positive number, we get the same answer as when we add a negative number. For example, when we subtracted negative 1, we got the same answer as adding negative 1. We can also see that when we subtract a negative number, we get the same answer as when we add a positive number. When we subtracted negative 1 and added positive 1, we got the same result. Therefore, subtracting a number is the same as adding the opposite number. Let's take a look at some larger integers. Negative 25 minus 75. If we complete this problem on a number line, we can see that the answer is negative 100. If we change the problem to add the opposite number, it becomes negative 25 plus negative 75, and we expect the answer to still be negative 100. We can prove on a number line that the answer is indeed negative 100. Therefore, the two equations are equivalent. Let's try 3/4 minus 1.5. When we find the answer on a number line, we can see that it is negative 3/4. If we change the problem to add the opposite number, we expect the answer to again be negative 3/4. When we complete the problem on a number line, we can see that this is indeed the case, and that the two equations are equivalent. Let's look at one last example. 1.5 minus negative 1.25. When we complete this on a number line, we see that the answer is 2 3/4. When we change the problem to add the opposite, we get 1 1/2 plus 1 1/4, and we expect the answer to still be 2 3/4. When we look on a number line, we can see that this is indeed the case, and that again the two equations are equivalent. In this lesson, you have learned to subtract rational numbers by using an algorithm.